Hey everybody, this is Larry. This is me going Q3 of the weekly kindness 447 concatenated divisibility. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. This one I did get a quick wrong answer on, but otherwise I think this is I don't know. I mean, this could be a tricky problem, but I think the first thing that you have to look for in this problem is the constraints. And for me, the constraint is that n is equal to 13. N is equal to 13 means that I'm able to do n times 2 to the n, or even n squared times 2 to the n if I really wanted to, and that'll be fast enough. And that's all I needed to know, honestly, because I know that I can brute force everything, right? I mean, of course, you cannot do 13 factorial, so that would be a little bit sketchy, but 2 to the n times n squared, which is, and I say that because that's a very common bit mass dynamic programming. I don't know. I think maybe now I like to call it like all possibility dynamic programming, because I feel like bitmask is an implementation name, and I think it doesn't really help anyone understand the thing at all. But yeah, it's just basically enumerating every possibility. And the way that I constructed, I mean, the tricky part about this is that you need to know the output, but we'll see how we kind of reconstruct the path, now, right? But it is just dynamic programming, and I forgot to sort. That's why I got a wrong answer. But yeah. First of all, let's go over. Okay, so yeah, I do have some. So bitmask, right? I just want to do like a 1 minute thing on bitmask. Hopefully not too long. The reason why I don't like bitmask dynamic programming, the name, the DP is fine. Bitmask is a little bit confusing, is because bitmask is the implementation detail, not necessary to understanding, right? And the idea of having bitmask is just that, actually, I think my complex is a little bit wrong in what I said, and I'll show you why in a second, but I just mean like that's all I needed to kind of go on. But anyway, yeah, the bitmask part is just to show that it's all possibilities, right? Because here, for n items, there are 2 to the n number of possibilities, right? Of like each element, either you used it or you didn't use it, or whatever, right? So if there are 2 states for each element, there's n elements, is 2 to the n number of states, right? And that's basically the core idea about this bitmask. And bitmask, the way that it is just, it's a number, but if you think about it as a binary number which doesn't have a 9, it just means that you can convert this to a Boolean array where it looks like this, right? And this is true or false, and then you just do operation that checks whether this is a 1 or 0, which is whether it is true or false. Okay, and then there's some pre-processing. I mean, we could do it in some order, talk about it in some order, but this is pretty straightforward, right? This is saying, so we have digits for each number in nums. We just count the number of digits, and and I actually changed that to 10 to the power of that, because that's the number that you have to shift by. What I mean by that is, if a number has 2 digits, you want to shift it by 100. We'll talk about that in more detail in a little bit. But yeah, but bitmask, now, this is the DP. We also know that we have the leftover, because that's the thing that we have to check for 0, right? So here, leftover is to 0 to k, which can go to 100. I guess it's 1 to k. No, it's 0 to k. No, it's 0 to k minus 1, but it goes up to 100 anyway, right? And mask, as we said, is going to be 2 to the n, which is about 2 to the 13, or I guess exactly 2 to the 13, right? So that's the number of states, right? Yeah. The complexity is always going to be like, how many, so complex or time complexity, the formula is simple. It is the number of inputs times time per input, right? Straightforward to understand. The number of input is going to be 2 to the n times k, right? And then each input takes O of n time, and that's it. Oh, that's the thing that I was trying to write, right? Okay, so yeah, so base case, this means that if we used all the masks, then we have to check. That means that all the elements are used. If all the elements are used, we have to check that the leftover is 0, and leftover is just the leftover from the multiplier thing, right? Or the leftover, the resulting, the remainder after dividing it by k, right? So that's 0, that means that is divisible, and we return true, otherwise we return false. Remember, we only need to return true or false whether it is possible, and if it's possible, then we return the lexicographically smallest one. Yeah, and the reason why we can do it this way is because even though there is a lexicographic, and I got this wrong anyway, so excuse me, but lexicographically smallest means that after we sort it, we can't just get the first element, because we're going from left to right, and we're constructing the element from left to right. All we have to care about is minimizing the first element. Actually, am I right on this? Huh. Actually, I think my code is wrong. Maybe. I think my code is wrong, actually. Sorry, give me a second. Okay. I think that's okay. I think my code is right, but the way that lexicographically smallest is so weird. The way that they divide it. I think actually no, my code is right, but yeah, because I think the other way that you well, actually no, this is not the right input. What is the proper input? So okay, maybe we have sorry, give me a second. Anyway, this code is still, we can fix it so that it's right in either case, but I'm just trying to figure out like so what I'm trying to debug and realize right now, my apologies, this is recorded live-ish, is that if I had something like I mean, I have to kind of get the right answer for it, but if you have something like this, in theory, because the way that I sorted it, I sorted by the numbers, right? The way that I sorted it, 3 gets sorted after 12, right? But in theory, this is a smaller number, but I don't know, maybe they just kind of lexicographically. Oh, I guess when you consider it as a list of integers, then this is right. I think we're right, but it is very awkward the way that they phrase it, because I think, I mean, and it's an easy fix, right? Because we just sort by lambda key is equal to the strength of x, and we just sort it by that. And I think this will give us maybe the, oh, well, no, that's just because of this. Oh. What? Oh, no. It's key is equal to this lambda. Sorry, friends. Yeah. See, okay, so I see. So this would, okay. So I guess it is in the example, but I just thought that now there's maybe 2 ways to read it. So my code was correct, my fault. But in any case, yeah, now that we sorted correctly because of this problem, we can just do each index one by one, right? If we haven't used this index, then we want to use it. Well, we want to use it, then we have to calculate the new remainder. And this is how you calculate the new remainder. You shift the previous remainder by this, and then you add it by the current number. And this is kind of yeah, because basically if your last remainder, and you could feel free to kind of do your own, but let's say k is equal to 10, the last number is 4, the last remainder is 4, and then now you have the next number is like 58, right? Well, when you concatenate the 4 to the 58, it is equal to, what is that equal to, right? Well, it just equals to 4 times 100 plus 58, right? So that's how you get 458 when you concatenate. And then now you divide it, or you do the mod thing by k, and that's why I have it this way. So and this digit we already, it's not the number of digits, it is power of 10 to the number of digits, so it's already shifted for you, right? So basically all this part does is shifting leftovers, the number of digits that we have, and then we add it by num sub I, and that's the new thing. And then we do a memorization based on that, and if this thus gives us an answer, then we update that from this input we're able to get to this answer, right? We want to take I, and then this is the leftover because we already calculated, that's all. And that's it, right? And also, yeah, each input takes all of one space, right? So now time complexity is going to be 2 to the n times k times n, and space is just 2 to the n times k, right? Oh, big O, maybe you want to add that. But yeah, that's basically it. Yeah, and then now we just calculate it, and if you cannot get there from having everything be open, this is kind of, it's not the base case, but it's just like the starting case, right? Where you haven't used anything, and by default it's just left over 0. If you cannot get an answer, then we return empty array. Otherwise, we just kind of walk through it. So we start by 0 0, current and leftover, and yeah, and then we just walk it one at a time. We go to the next one, we append the number that we have from that index that we have, and then we update the current, we update left, and that's it. This is linear, right? So I'm not going to go over that. Linear time, and no extra, well, I guess linear space to do the answer, but this is obviously going to get dominated by this. So yeah, that's all I have for this one. Let me know what you think. I think this one, if you're having trouble with this one and my video isn't detailed enough, I think it's just because this particular problem is it's just bitmask. Like if you have to understand bitmask dynamic programming, like I said. So definitely there are a lot of problems. Practice those, and then the only other part is like the shift and add and mod thing. I think that's the only thing that's a little bit different, and maybe calculating the number of digits. The path construction could be a little bit tricky as well, but you just have to practice that. I think it comes up unfortunately more and more these days, so you have to kind of think it through. But yeah, let me show you the DP code again, the top pre-processing code, and then the bottom path reconstruction. And that's all I have. Thanks for watching, and you can watch me solve it live during the contest now. Force, and then force true. All right. Hopefully no silly mistakes. Okay, good. This is now finding a hard problem. Okay, you're giving it. Okay, what is n? N is 13, so I really want to do bitmask dynamic programming probably. Oh, wait, no. It's the smallest, huh? 13 factorial is going to be too small. I mean, it's still going to be bitmask DP, right? I don't think there's anything that tricky about it. And it's just greedy, right? So yeah. Mask before. Yeah, I mean that's fine, but if mask is which way do I want to go? Yeah, just set to 0, fine. It's a little bit annoying. Okay, so then now okay, and then now we want to write for image of n. Leftover times digits sub I. Oh, it's 10 times digits sub I, so this should be this. Okay, it's not quite. The naming is off, but that's fine. Plus num sub I mod k, right? I don't know, this is me just being lazy, maybe. Right. Okay, and then now we calculate from no use, no leftovers, and then we go, okay, well, is it always possible? Or we turn an empty list? It's not possible, we turn an empty list. Otherwise, then now current is equal to mask 0, 0, 0. I mean, this is technically right. I want to be a little bit cleaner. That's the mask. That's the leftover. Okay, so then now we want to say next of current index new leftover index, and then current is equal to okay, that's just lazy Larry. Let's just say current is equal to 0, left is equal to 0, and then now we just do. Oops. And then okay, current is then now you got a current index left is equal to new left, and then we're good in theory. Oh, it's not, you don't append the index, you append the nums of the index. Key error 0, 0. That's wild. This is empty. Oh, I did this wrong. I'm dumb. Yeah, I'm just being dumb. This should be. I don't know why I keep changing my mind. Okay, 3, 12, 4, 5, 5, 10 should be good. Let's try. A big permutation thing. Looks pretty fast, but that's because this is what. Okay, still looks pretty fast. Let's YOLO submit. Come on. Oh no. Oh, do I have to do lexicographically smallest? But why is that wrong? Why am I wrong, rather? If I do 3 and then 6. Oh, I don't sort the input. Because the input is 6, 3. I am dumb. I assumed the input would be sorted. So I did it in index order. That's why. Okay. That is a dumb mistake. Hopefully that's it. Okay. That is a dumb mistake then. Alright. Second heart. How am I? Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about each problem, this problem. Stay good, stay healthy, take your mental health. I'll see y'all later and take care. Bye-bye.